So today we're going to do 11.5, which is areas of circles and sectors. Yesterday we talked about like the crust of the pizza, right? We talked about the edge. Today we're going to talk about the area. That is, how big is the whole pizza itself? How much cheese and pepperoni is there? All right? And anchovies. I know, gross. Right? Why people eat fish is beyond me, okay? When fish goes bad, it still smells like fish. It's like, ew. Right?
The freshest fish doesn't taste like fish.
I don't try, I am. The area.
It's not working.
The area. The area of a circle is pi r squared. Pi r squared. We're going to skip that problem actually because it's really terrible. I had a typo. So we're going to go right to the next one. So the area of the circle is pi r squared. R again stands for the radius. So these are some quick practice from yesterday. Find the circumference of a circle with a radius of 8 centimeters. What is my formula for circumference, Benny? 2 pi r. So I plug it in. The circumference is equal to 2 pi. Is this the radius or diameter? So I plug it in 8 centimeters. So I get c is equal to 16 pi units or centimeters. Why did I want you to leave it in terms of pi again? Somebody raise their hand and tell me why I was doing that. Anthony? What do they do on the SAT?
They're gonna give you the answer in pi, not
Right, because they want it to be not a disadvantage to those without calculators, although they already are anyway. Okay? So, 16 pi. Find the radius of a circle with a circumference of 24 inches. Can somebody work that one out for me, please? Raise your hand. Somebody work that one out. You know?
Would it be back to the formula?
Which is? Yep.
And we put 24 equals 2 pi x.
Sure, I'm going to leave it as r. Can we just leave it as r? Okay. Keep going.
Don't you divide?
5. 2. Can I do anything else in that same step? And what else could I divide by? 5. Let's just do them both at the same time. So divide by 2 pi. So the 2's cancel, the pi's cancel. Not 12 pi. Where is pi? Is it numerator or denominator? So it's got to stay in the denominator. So it's going to be 12 over pi. What are my units? Inches. If you give that to me on a test, perfectly fine. I may, in fact, ask for them in the test. On the test, I may say, give me the answer in terms of pi. So you could definitely type this out. What is it, Gloria?
3.82.
3.82. So you could definitely give me that answer, but I may on the test require you to give me it in terms of pi. Okay? If I don't specify, I don't care. But a few of them I might ask specifically to give it to me in terms of pi. All right? Easy enough? All right. Today, we're going to talk about sectors. Like I told you, yesterday, we focused on the crust of the pizza, the arc length from A to B. Today, we're going to talk about the whole pizza, right? The whole slice. A sector is like a slice of pizza. Think you want the area of the pizza, right? You don't care usually how big the crust is. You care how much cheese and pepperoni and everything else there is, right? Unless you really like crust.
Mm-hmm.
All right? So the area of the sector is very similar to how we found the area of the arc length, or not the area of the arc length, how we found the arc length yesterday. You'll notice it right away. So it's the area of the sector, so I'm going to write a little subscript underneath. So the area of the sector is equal to the arc measure over, what's it going to be over? 360, because we want to know how big is my piece. This part tells me how big is my slice. Is it a small skinny slice or is it a big fat slice? Okay? Times, instead of the circumference, which we used yesterday for the edge, for the crust, now we're going to use the area of the circle. What's the formula for the area? What is it?
R squared.
Pi r squared. Yes, a equals pi r squared, but we only want the pi r squared part. So notice this is remarkably similar to yesterday. We have whatever we want equals arc measure of 360. That's completely the same. Yesterday we did times the circumference. Today we're going to do times the area. Okay? Yes?
What are our area structures? Like, what are the units?
It's an area, so what would it be?
Squared.
Yeah, unit squared, whatever it's going to be. So it's whatever the radius is squared. So if the radius is inches, it would be inches squared. Okay? All right, it says find the area of both sectors formed by angle UTV. So notice that there's a reddish sector and a, I don't know what's wrong with this projector. On my screen it's like nice and blue, but it doesn't come out very well. So it's supposed to be red and blue. Okay? So if I want the area of the red sector, the area is equal to, what's my formula? Somebody have it for me? Ernest? Arc measure over 360 degrees times pi r squared. Very good. And we're going to solve these the same way we practiced yesterday. So we need to find the area. I don't know what it is. What's my arc measure for the red? My arc measure, Mauricio? 70 degrees over 360 times pi, what's r? 8. Times pi 8 squared. Easy enough? Plug and chug? Still with me? What did we do yesterday when we got to this step? Reduced or simplified. So I'm going to cancel the zeros off, because we can divide both of them by 10. So I get 7 over 36 times, what's 8 squared? So it's going to be 64 pi, but I'm going to put it over what? 1. Now you notice how similar this is to yesterday?
Yeah.
Multiply across. I don't know what that is. What's 7 times 64? What is it? 448 pi over 36. Now, if I said you could just write it in a decimal form, go to your calculator, type that in. If I said I want it in terms of pi, you're going to have to reduce, because the odds are that they have this answer shown in one of their multiple choices. It's probably not going to happen. All right, Evelyn?
So on the calculator, you would put parentheses on the 448 pi. So make it right. And then divide it by 36.
So good question. The question is, when you type it in, you're going to get 448 pi divided by 36. Do we need to put the parentheses around the numerator? Actually, we don't. You should get in that habit. It's a good one to get into. But remember, it's going to end up doing order of operations. So it's going to do 448 times pi first anyway, right? And then it's going to divide the whole thing times 36. However, what it's good to get in the habit of is, if you have something like x plus 2 over 4, like that, something like that, if you didn't put the parentheses here, it would do the 2 and the 4 first, and then the x. So there's where you would need them. So it's probably a good habit to get into. Okay, better safe than sorry. What goes into both of these? Anything? 2, anything bigger? 4. 4 goes into both of them. Let's do 4. 112 pi over 9. Anything go into both of those? 3 goes into 9. Does 3 go into 112? Did you check it?
There's a decimal.
There's a decimal, so it doesn't go in evenly. So can we reduce that any further?
No.
So your final answer is 112 pi over 9. And when you check your answer choices, this is what's going to show up. So even though this is still correct, you may not find it in a multiple choice question. You have to be very careful. Yes, there. I will be very, very clear about my directions. So it will depend on each problem. So a problem may say, I would like you to express your answer in terms of pi in simplest terms. In that case, yes, you would need to simplify. Other ones, I may say you can express your answer as a decimal. And then I don't care. Right? Yep.
What's the way that we can check? Is it right? No plug and check, no input.
One way you could do a rough check is you could find the area of the whole circle. So if you just did pi r squared, it would be 64 pi. And then find out what part, it would be easier to do with decimals. But if you got your exact answers, you could say, does my piece look like it's that percentage of the whole thing? So for example, if my angle was almost half, was my answer about half of the whole circle? It's really hard to check these. Not really a good way. The other thing I want to show you, if you're stuck reducing, and you're looking at your answer choices, you have this, you have the 448 pi over 36, and you want to find your answer choice, and you can't find it there, go to this, type it in your calculator, get the decimal, whatever it is. So what is that going to be? 39.10. Then just go to your answer choices and start typing your answer choices in your calculator. Right? It's going to be the same number, right? So if you're having trouble getting exactly what it looks like, start typing their answers into it and see if any of them come up as 39.10. If none of them come up, then you've made a mistake. All right? So let's say I don't know how to simplify it all. If this is my answer choice, I plug that in, I get 39.10, and I'm like, oh, hey, these must be equal. So this is going to be my answer. Okay, so that's another strategy to help you do well on the test.
If they put two that they both give 39, that's not possible, right?
They will not give you two answers that will both give you 39.1. So they'll give you most likely the most simple version.
But it can happen.
Yes, so one thing, another sidebar, something like 2 over root 2, let's say you get that as your answer. Well, you look at your other stuff, and there's like 1 over root 2, there's 2 root 2 over 2, there's 3 root 2 over 2, and you're like, well, this is what I got. None of my answers are matching up to that. Right? And you don't know how to reduce this or how to play with it to get to the other things. Type it into your calculator. Find out what decimal you get. Okay? Do this real quick. Type this into your calculator and tell me which one is it going to be, A, B, or C. So type the first one in. What do you get for a decimal? 1.41? Oh, I messed up. Actually, no, it's this one. Did you get me the first one?
No.
Did you get the same decimal? No. What about the second one? You got 0.707 for this one, right? That's 0.707. Is that going to work? Type in your last one. Did you get 1.41? Yeah. Do you know how to get from here to here? Maybe not. You will eventually next year. But right now, you don't know how to switch this, right? Well, just because you don't see your exact answer doesn't mean that the correct answer isn't there. Does that make sense? All right. Long detour. Let's go back to the problem. Okay? The blue one. Formula. What's my formula? Formula. What's my formula? Mauricio?
Arc.
The arc?
Arc.
The area.
Our area sector is equal to arc measure over 360.
Over 360.
It's equal to times pi r squared.
Pi r squared. So what are we looking for? What's my unknown?
The area.
The area. So the area is equal to, what's my arc measure going to be for this one? Raise your hands, please. Area? Yeah, we want to find the measure of this piece, right? So in order to find that piece, we have to do 360 minus the 70. So what's that going to give me? 290. So it's going to be 290 over 360 times pi, what's r? Times pi 8 squared. So the area, I can divide both of those by 10. So the zeros will cross out, so I get 29 over 36 times, well, this is exactly the same as what we had before, right?
Yeah.
So it's going to be 64 pi over 1. 29 times 64? Sorry, what is it? 1,000? 1856 pi, don't forget your pi, over 36. That's going to be a beast to reduce. Let's just call it good. What's the decimal going to be? I won't spend our time doing that. On your test, I'll make sure that they're fairly easy to reduce. I won't give you anything like this ridiculous.
51.5.
51.5-ish?
Yeah.
What are my units?
No.
One.
Oh, sorry.
One.
I'm sorry. Hang on. Guys. Be polite, alright? Or does anyone have a different answer? Marcel? 161? Did anyone else get 161? Okay. George, I'll take a look at it in a second. 161.97. What are my units? Units squared, because we're finding the area. Unit squared. You divided by the answer. I think you divided twice. Ladies and gentlemen, what I want to show you, one thing that might help. One other thing that might help. You can simplify across multiple signs. So notice right here I had 29 over 36 times 64 pi over 1. You can simplify across a multiplication sign as long as they're in the numerator and the denominator. So in this case, we have 36 and 64, correct? We can divide both of them by 2.
By 4.
Can we divide both of them by 4?
Yeah.
Yeah, so let's divide them both by 4. 36 divided by 4 gives me
9.
And 64 divided by 4?
16.
16. Do you see how much that makes it easier now? So then you're just going to do 29 times 16 would be what? 29 times 16?
464.
464 pi over 9. So it's a little bit simpler than this version, right? So you can reduce before you multiply them together. So you'll stay with smaller numbers that you guys have memorized already. Right? These will be exactly the same. Ernest?
What are we trying to find?
The first problem, we were finding the area of this slice of pizza. We want to know how big is this slice of pizza?
Is that sector or object? The front.
That's the area of the sector. So that slice, a slice of pizza is called a sector. Okay? Hey guys, what's the area of the whole circle? The area of the whole circle, not the measure, the area. No, we got to add them both. We have the red, we have the blue. All you need to do is add them together. We would add our final answers. So the blue one plus the green one, that would be our final answer, okay? Don't worry about it, I don't want to do it. Alright. Trisha? Watch out, back, please. Jason, up here, please.
The whole circle is 360. It's not always going to be big. Because you're the best.
Be careful. every circle is 360 degrees for the arc measure. But for the area, they're different because every circle is 360 degrees around, right? Even if it's big. But the size of the circles is very different. Does that make sense? So if I make a complete spin, it's always 360, but it's the size of the circle that changes. So it depends also on the radius. Okay. Yep.
Did you ever solve a problem with just cutting up big pieces and then like flipping it, like, you know what I mean? Like, if it was a four-sided stuff, and you cut it in half and you got one of them, then you could just throw it like this.
By 4. But yeah, sure. But then that would be a really long way.
Yeah.
All right. The other way we can do this, what's missing here? What is missing? Radius. So we're going to use the same formula, except now it's just going to be a different way to solve it. Formula, please, Chris. Formula. What does A stand for?
Area.
Of what part? Of the sector. Very good.
Arc measure over
The arc measure over 360
pi r
times pi r squared. Darren, what's my area of the sector? What's my area of the sector? 40 is my measure of the sector. 35. You see that's capital A? Capital A always means area. 35, I'm going to drop the units and we'll pick them up at the end. What's my arc measure, Ariel? 40. 40 what?
No, 30 degrees.
Thank you. 40 degrees over 360 degrees times, do we know r?
No.
So let's just leave it as pi r squared. So we get 35 equals, can we reduce that?
Yeah, to 4 and 9.
So not 4 and 9. We can cross the zeros.
1 and 9.
1 and 9.
1 and 9. Because 4 goes into both of them. What should I do the next part? Make it a fraction. So do pi r squared over 1. So 35 equals, we need to multiply across.
1 pi r squared over 9.
And we can drop the 1 though, because if it's 1 pi r squared, it's just pi r squared. Over 9. We need to get what by itself? Yeah, the r eventually, but pi r squared first. How do I get rid of the 9 then?
Multiply 9 by 1.
You multiply by 9. You know, we multiply because it's currently being divided. We need to do the opposite.
Oh.
So we multiply both sides by 9. These will cancel. What's 35 times 9? 315 is equal to pi r squared. Next step is we divide by pi on both sides. Guys, don't touch your calculators. Take a look. What is pi?
3.14.
What's 315 divided by 3.14 going to be? About. It's going to be about 100. Type it in your calculators.
You got 100?
Shouldn't be 116.
Oh,
Yep. Divided by pi, yep. So it should be r squared is like 100 point something. 100.3.
100.2.
Guys, I don't care. Alright? If it's 100 point something, close enough, alright? So please just don't argue with each other. The difference is some people are using the pi as the button, and some people are using pi as they're typing 3.14. It would be better for you to use it as the button, because if you use it as the button, it'll be more accurate. Okay? And then, what do we do to get r? Square root of both sides. So the r is before you touch a single button. Think about it. What's going to be the square root of about 100? 10. Type it in.
10.1.
It's going to be 10.01 or something like that, right?
Yeah.
10.02? So it's 10.02, which is approximately, I'm just going to call it 10. Is that okay? Do you guys understand how I'm doing this without a calculator?
Yeah.
I just want to show you that you have a calculator up here, right?
Don't work.
Don't work. Need some new batteries. Alright. What are my units for the radius? Meters. So the radius is 10 meters. Guys, this is great. You nailed your SAT problem. And then you look for your answer, you see 10, you bubble it, you move on. You're right.
Yeah.
Yeah. Except you're wrong.
What you mean you're wrong?
This is going to take longer than...
Why are you wrong? Yes, you found the radius. That's great. Super.
Oh!
So now you need to do what? Plug it back in to the area of circle V. What's the area formula for the circle? No, just the area for the whole circle. Whole circle. Sorry. Pi r squared. So this is my r. I plug it in. So the area is pi times 10 squared. So the area is 100 pi. What are my units?
Meters.
Is it an area or a distance? So what's meters? Meters squared. We know it's meters because they gave us meters up here in the problem. Ariel? Hang on. Guys, focus. Questions, please. Questions. Penny. And this is why you do your homework. Because homework makes you do it fast. Alright? Homework lets you skip steps. When I do these, I don't write this. Okay? When I do these, I don't do this over one. I already know that it's going to go to the numerator. Okay? It lets you learn your own steps to skip stuff. Okay? The other thing is when you do your homework, you don't have to think about these. When I see a problem that says find the area of circle, I'm already thinking pi r squared. Right? So you got to train your brain to get used to them. Risha?
You did this on purpose, right? Like that problem, you did it on purpose. Or like for every problem, we have to look at our numbers and kind of try to guess what's going to be like, oh, like,
No, you don't have to, but you should get in a practice to do it. Because for example, Jason, Brian, for example, a lot of you are very willing to believe whatever the calculator says. Right? Even if you type them in wrong, you guys are like, oh, well, the calculator said it. The calculator is never wrong. Just like I'm never wrong. Sometimes I mess up and you guys are like, oh, he's the math teacher. He knows what I'm doing, right? No. Okay, maybe you think that. But you guys, like, the calculator doesn't make mistakes, actually. I make mistakes. What the calculator does is it interprets whatever you put in a different way from what you think. So what you type in, you think you entered it right, the calculator sees it in a different way. Okay? That's why the parentheses are so important. So I just wanted to get you used to, if you made a mistake here, maybe you did 315 times pi, you'll get 900 something. You guys will just keep going. Well, you got to think, well, 315 divided by 3, 300 divided by 3 is not going to give you 900, right? So you got to think about that sort of stuff as you go along. All right? You are welcome to skip steps whenever you want. My rules are always that I want to see your work, and that if you skip steps, I don't give you any credit for what is not there. Okay, so you're welcome to skip steps, but skipping steps does not mean just writing an answer. You're welcome to skip small steps. You're not welcome to just 17. All right? Okay. We'll do this as the last problem for today. We'll do this one as the last problem for today. Brian, are you okay sitting there? We need to move. You sure? You focused? Okay.
Which green are we trying to pick? The green one?
Standardized test prep. Okay? You would like to paint the gym floor. We're going to paint it green. Okay, that was a little unclear. We're going to paint it an ugly green, right? But we want to leave the basketball key white plus like the little piece above it. When I saw this, I thought it was a basketball key, but it turns out it's not really. But just go along with it, okay? What is the area of the region you want to paint? So which color is the area we want to find?
Green.
Green. All right? Any thoughts on how I would start this? No numbers yet. No numbers, just words. How would I start this? Aaron? So we need to find the area of the white space at some point, right? What else? Mauricio?
The area of the square.
What do you mean by the square?
The square is right there.
Which rectangle?
The outside of
The outer edge of the whole thing.
yeah.
How could we combine the outer edge and the white part to get the green part?
Minus.
Subtract.
Yeah.
So the area green is equal to the area total, TOT stands for total, minus what? The area of the white space. Minus the area of the white space. Does that make sense to people?
Yeah.
We're taking the whole piece, and somebody took a bite out of it, and they took it away. Okay? So the area of the total, I'll outline this in black. We want this area. That is a rectangle. Do we agree with that? So the area of the total, what's the formula for a rectangle? Length times width. So it's going to be 26 times 36. What's my area for that? 936?
Yeah.
Okay, I'll leave it unitless till the end. Leave it naked. Alright. Any questions on the area of total? We now need to find the area of the white piece. Well, the white piece is actually two different pieces. Right? We have the square here, and then we also have the semicircle on top. Do we agree with that?
Yeah.
So the area of the white is equal to the area of the square. Am I going to plus or minus the area of the semicircle?
Mine.
Plus. It's in addition to. It's not taking it away. We have the square and we're adding this much more to it. Okay? So plus the area of the semicircle. Alright, if you want to write out semicircle, that's fine. So the area of the square is going to be, what are the dimensions of the square? Yeah. So it's 16 squared, right? Because the sides are the same? Plus, we want a semicircle. The area of a semicircle. Do we have a formula for the area of a semicircle?
No.
No, but it'd be pretty hard to get. It'd be pretty easy to get, I mean. What is it? Divide by 2. Because a semicircle is half of it, right? So it's plus half of, what's a whole circle? Careful. Area of the whole circle. The area of the whole circle. What's pi r squared. Pi r squared. Alright. We're looking again for the area now. The arc measure, remember, is how many degrees. So it's how wide an angle is. Here we're asking for the area. If I asked you for how big is a pizza or how big is the key, you wouldn't tell me 360 degrees. Right? So let's plug in. What is r? 8. So it's going to be pi 8 squared. I don't know what the deal is with 8 squared today. The radius has to be half of this, so it's going to be 8. 16 is going to be the diameter for the whole thing. Does that make sense? When is an emergency? Can you go when? No. Oh, you're good. Go ahead. You got what? It gets up to 8 squared. So this is equal to what, 16 squared? I know it. 256 plus 64 pi. What's 64 divided by 2, though?
32.
32. Do I need to write that out or should I? Can I skip that step or no? Let me write it out. So I'm going to have 1/2 times 64 pi. Do you agree with that? 1/2 times 64 pi? So then I get 256 plus what's half of 64? So 32 pi. So I've got the area of the total. I've got the area of the white. What do I need to do now? So area of the total plus the area of the white? Subtract them. Remember, go back to what we wrote earlier. The green is equal to the whole thing minus the piece that's been taken out, which is the white piece. Okay? So I pulled that piece out. Patricia?
Can't we multiply 32 by pi and then add 256?
Yes. What I want you to do, though, is to leave it in terms of pi. Patricia said, can we take a calculator and do 32 times pi? Absolutely. It would be 90-something. And then add it to 256? Sure, we absolutely could. I want you to keep it in terms of pi, though, okay? Because I know you guys can do that one. That's why I'm always going to do the harder version. You guys can always just plug it in a calculator. I'm going to keep it in terms of pi, because it'll be a little more difficult. Mauricio? This is as simple as we can get it. Think of this as 256 plus 32x. They're not like terms, so we can't combine them. One has a pi, one doesn't. Darren?
So what do you do from there?
So now we need to go back to our original equation. We said the area of the green is equal to the area total, which is 936, minus the area of the white. Now, the area of the white is the whole thing right here, right? The two terms down here. So if you're ever going to do that and you want to plug it in, you got to put it in parentheses, because we want the whole thing subtracted. So it's going to be 256 plus 32 pi. Okay? Mauricio? Absolutely, and that's why we put it in parentheses. We have to put it in parentheses because I want to subtract the entire thing. And so in order to subtract the entire thing, we have to subtract not just the 256, but also the 32 pi. So this negative sign distributes to both terms. Just like when you had, I don't know, 2 times 3x plus 2, you would distribute the 2 to both of them. Here we're going to distribute the negative to both of them. So it's going to become 936 minus 256. What's that going to give me? 936 minus 256 is what? 680. And then this is going to be plus 32 or minus 32? Minus 32. Can we combine it with the 680? No, because if the 32 has the pi, the 680 does not. So minus 32 pi. Okay. Can I combine those? No, because one has the pi, one does not. What are my units? Feet squared. Because what did I find? I found an area. Area is always units squared. So here are the feet squared. Now, exactly. Now, here you start looking for your answer choices. You look for the one that matches that. You can also very willingly type that into a calculator and see what the decimal would be. Does anybody have the decimal available? Hang on one second. Hold on to that, Anthony. Why did I change it to a negative? This part? Why did I not subtract these two? Because they're not like terms. This does not have a pi. So it would be like 10 minus 3x. I can't say that that's 7x because this has an x and this doesn't. Same type of deal right here with the pi. What did you get, Leo? 579 point what? 47 feet squared. Close enough. 37. I don't know. Whatever. Patricia?
I understand that you can't do 936 minus 32 because they're not like terms, but when they were not like terms, you would just put it in the other side and put something like 936 minus 32.5. Because, like, how can you just, like, drop it? Like, just carry the sign.
I'm confused. Can you ask that again?
Like, you know how we have to do distributive, so we have to go to both.
The negative sign, yes?
Just the negative sign.
In this case, yes. If it were something like 936 minus 256 plus 32 pi, you would distribute the negative 2 to both of them. So it would be a negative, and then it's this times 2. This would be a negative, and then it would be 32 times 2. In this case, though, it's like a negative 1 that you distribute to both.
Oh, okay.
Okay. Let me stop the recording.